In this video, we're going to look at a special probability distribution called the normal model. This is one of the most widely used probability models for continuous numerical random variables. The normal model always is going to have this bell shape like you see here on your screen, and it's completely described by the mean and the standard deviation. It's also called a bell curve because of this shape. Here's a histogram for heights for a sample of males. This histogram is symmetric and unimodal, so it can be modeled using a normal distribution. Here are two examples of normal distributions. Both the blue and the red curve are bell-shaped and unimodal. However, we would describe the blue curve as having sort of a wider spread. And remember, spread is measured by the standard deviation. So this is going to have a larger standard deviation, whereas the red curve here is going to have a smaller standard deviation. Both curves have the same mean. The mean here is in the center of the curve, and they're both centered at 0. The area under both curves, since they are probability distributions, the area there is going to be 1. These normal curves on your screen show the distribution of heights for adult men and women in the United States. Here, notice that the spread of each curve is about the same. However, the center of the curves are different. So these curves have been shifted to so that they are centered in different spots, right? So for women, the mean height is around 64, whereas for men, the mean height is closer to 70 here. With our normal distributions, we're going to introduce some notation. We're going to use this symbol mu here to represent the mean of a probability distribution. And we use the symbol sigma to represent the standard deviation. So to describe a normal distribution with mean mu and standard deviation sigma, we're going to write a capital N and then parentheses mu comma sigma. We are going to take advantage of the technology available to us to find probabilities in a normal distribution. However, it's always helpful to start by sketching a picture of the area you are interested in finding before using the technology to find the area. The picture will help you to identify what the endpoints of that area that you're interested in are. Most technologies will require you to enter the mean and standard deviation of your distribution, as well as specifying the interval of the area you are finding in the normal model. Let's look at an example. Women's heights can be modeled with the normal model with mean 64 inches and standard deviation 3. Let's find the probability that a randomly selected adult woman from the United States is between 62 and 67 inches tall. So remember, our first step is always to draw a picture. Now your picture doesn't have to be perfect, but you want to draw a bell-shaped curve with a center at 64, since our mean is 64, and a spread of standard deviation of 3. Okay? And then I want to mark the area under the curve that I'm interested in. Here, I want to know the probability that a randomly selected adult is between 62 and 67 inches tall. So I'm going to draw a line at 62 here and another line at 67, and I want to shade the area under the curve between 62 and 67. Now that area is going to give me the probability that a randomly selected adult woman has a height in that interval. Okay, so how do we find that area? Well, we're going to use StatCrunch. So we're going to go to Stat, and then Calculators, and then Normal. Now what pops up here is going to be a picture of a normal curve here, and we're going to tell it the mean and the standard deviation. So we know that the mean height for women is 64 inches and the standard deviation is 3. And I'm going to select that I want a probability between two numbers. So I'll tell it between 62 and 67. And then I'll hit compute here and that'll spit out the 0.588852221. Let me show you that actually in StatCrunch. So I'm going to escape here and pull over my StatCrunch window. There it is. All right, so here is StatCrunch. Let me make it a little bit bigger. And so remember we said we're going to go stat, calculators, and then normal. So stat, calculators, and there are lots of options. We want the normal calculator. I'm going to go ahead and make this a little bit bigger. There we go. All right, so it defaults to a mean of 0 and a standard deviation of 1. So I'm going to change that. My mean was 64. Our standard deviation was 3. And here it also defaults to finding the probability that x is less than or equal to 0. Now I wanted the probability of getting something between two numbers. So I'm going to click on this between. And now you see it's switched so that I can give a lower bound and an upper bound. We wanted between 62 and 67 inches. And then I'm going to type compute. And there we go. So the probability of selecting, randomly selecting a woman with a height between 62 and 67 inches is approximately 0.59. Let's look at another example. This is about harbor seal pups. Research has shown that the distribution of a newborn Pacific harbor seal's birth lengths is approximately normal with a mean of 29.5 inches and a standard deviation of 2.5 inches. What's the probability that a randomly selected harbor seal pup is longer than 31 inches? Okay, so here I want the probability that it's longer than 31 inches. So I'm looking for the probability that x is greater than or equal to 31 inches. Okay. Now the first thing you should do is sketch a picture. So before I flip to the picture on the slide, let's just pull out our pen and sketch a rough picture. So I'm going to want a normal curve. So here's my bell-shaped curve. Whoops. Oh boy. Can I undo? So there's my straight line. My mean is in the middle, and I know that the mean was 29.5 inches, so I'm going to mark 29.5 here. And I have a standard deviation of 2.5 inches. So this is a normal distribution with mean 29.5 and standard deviation 2.5. Okay, I want the probability that a randomly selected harbor pup has a length longer than 31 inches. Let me switch my color here. Let's say gray. So 31 inches is not even one standard deviation away from the mean. So let's mark it here. So here's 31 inches. And I want the probability that it has a length longer than 31. So I am going to shade everything to the right of 31. All right, so that's the kind of picture that we're looking for. Let's flip the slide to see that a little prettier. There we go. And so we're going to do the same thing. So we're going to open StatCrunch, go to Stat, and then Calculators, and then click on Normal. I'm going to plug in the mean of 29.5, a standard deviation of 2.5, and I want the probability that x is greater than or equal to 31. Now notice there's a drop-down menu here, so if it wasn't set at greater than or equal to, you need to use the drop-down menu to switch the inequality. And that gave us a probability of 0.274. So the probability that x is greater than or equal to 31 is 0.274. Now you might be wondering, technically that question said greater than 31, and what we found was the probability that you're greater than or equal to 31. So did we do something wrong? Well, in StatCrunch, we don't get the choice of strict inequality because for continuous numerical variables, the probability that x is more than 31 is going to be the same as the probability that x is 31 or greater. Okay, so whether or not we include that endpoint, the shaded area is unchanged. So in this case, the probability that x is greater than 31 is the same as the probability of x being greater than or equal to 31. Now that is only true for continuous numerical variables. If your variable is discrete, that's not going to be true.